Sounds good. Thank you.
Good morning, everyone. Thank you for joining today's Lunch and Learn. We have Dwight Taylor doing Lunch and Learn today on Beyond Bar Charts. So I'm going to pass it over to Dwight. Thank you, Dwight. Good morning.
Good morning. Good morning. Thanks, Tawana. Okay, so everyone, welcome to today's Lunch and Learn. Really appreciate you all taking the time out to for this Lunch and Learn Beyond Bar Charts. Quick note, we do invite everyone to take the survey after the Lunch and Learn. It really helps the team make sure we deliver content that's valuable and engaging for you, and most importantly, helpful as you are on your journey and becoming productive and compelling with Tableau and producing visualizations that deliver insight and value to your viewers. Okay, so we invite you to do that. Okay, so today's Lunch and Learn is Beyond Bar Charts. What I thought would be a good idea is to talk about some of the techniques that the more experienced Tableau Zen masters and Tableau designers use to create charts that really, I guess I'd say, pop and maybe, deliver visualizations in a more compelling way. And the reason I called it Beyond Bar Charts is because the bar chart is probably the most dominant chart type in analytics, right? Other than a line chart, and the line chart is not most popular, the bar chart is most popular. And one of the reasons that it's most popular is because it's easy to compare things side by side, right? If you're looking over a categorical dimension or a time series, a bar chart is a really good way to sort of compare things. So we're going to look at a couple of chart types today, and we're going to walk through how to create them step by step, okay? All right, let's dive in. Oh, by the way, again, as we're talking through these chart types and as we're building them, if you have questions, feel free to jump right in. No need to wait until the end, okay? So we're going to talk about 3 types of unique chart types that can be created in Tableau. The first one is the lollipop chart. It's called a lollipop chart because it sort of resembles the resulting visualization that's presented, sort of looks like a lollipop. We're going to talk about a reverse funnel chart, and I'm sure some of you maybe have seen a funnel chart, maybe in the sales dashboard or something like that. Starts with the wide audience of wide population, and then the chart sort of narrows as you approach the end goal. Okay, so we'll look at that type of chart, and then we'll look at a speedometer chart, right? How do we create a chart in Tableau where a needle moves based on performance of some metric? What's the trick to some of these charts, particularly the reverse and speedometer chart? The trick is real simple, data shaping. And we're going to talk a little bit about data shaping. And we'll have another session at 1 o'clock. That session is also going to focus on data shaping, but from an optimizing your workbook perspective and not necessarily how to build sort of unique chart types, okay? All right, so if there are no questions, we'll jump into the demo. The first one is going to be the lollipop chart, and you can see here I have a lollipop chart, and it basically is the stick of the lollipop going from left to right. The stick represents sales, and the lollipop, or the sucker part of the lollipop chart, represents profit for those sales. And, if you're in an organization that sort of deals with sales and profit, this type of chart can be really compelling because, for example, this item here, Texas, is an outlier. Why? Well, it's the third highest state for sales, but the profits are the high, we lost the most money in Texas, quite frankly, if we look across the entire spectrum, right? And so what we're doing in this chart is, as I mentioned, sales is along the x-axis and the stick of the lollipop, and profit is the lollipop itself, and the size of the lollipop is based on profit and also color. And what we did is we used a color gradient to indicate black. Why black? Because normally in accounting, if you're positive, the nomenclature is that we're in the black, right? If you're negative or if you're not profitable, you're in the red, right? So the chart is sort of analogous to what you would expect in an accounting spreadsheet or an accounting chart, and the size also is sort of reflective of that. And we'll talk about this. So, the common question that I get, okay, well, if Texas was unprofitable, why is the lollipop sort of same size or near the same size as Washington, which is profitable? And we'll talk about that as well, visually representing negatives in a way that is compelling and understandable. Because if we think about this, if the size of the lollipop is according to profit and the profit is negative, how do you represent a negative size, right? And so for those of you who specialize in mathematics or sort of know this, you know the answer to this, but we'll talk about that as well. Okay, so let's get into building this chart. We'll get out of presentation mode, we'll create a new worksheet, and we'll start building our chart. So what we're going to do is we want sales, and there's our stick, right? That's sales. And we actually want a dimension here. Now, one of the things I did not show in the chart is I also built in a dynamic dimension so that we can rotate this chart. Right now it's based on state, but what if we wanted to look at it based on category, right? If we look at it based on category, we can see that all of the categories are profitable overall for the duration of the time that we're looking at, which is all time for this data. This is just the sample, the sample Superstore data. But if we look at region, we're still profitable in the aggregate. And if we look at segment, we're also profitable. But then when we begin to look, geographically, we can see a more compelling story, right? So we can see quite a number of states where our sales we're making sales, but the profit margin is really suffering in a number of states, and we can see that clearly. Okay, so how did I do that? First off, how do we rotate this chart based on this? And this is a very simple technique. Have a calculated field called dynamic dimension in addition to a parameter, and I'll show you the parameter. So the parameter is just a set of strings, right? A list of values. And I have 4 of them: category, region, segment, state, right? And then I create a calculated field based on that parameter using a case statement. So this is the name of the parameter. If the parameter is category, then I actually show the category dimension. Now this is a string, but this is an actual field in our data set, right? And so on for each of the 4 values that we chose to include. And you can include as many values as you like. And then instead of dropping category on rows in our sheet, right, where we can do that really simply, instead of dropping that on the sheet or region or the others that we listed, we drop our calculated dynamic dimension. And then we show the dimension so that we can rotate, right? I can go to category, I can go to region, segment, or what have you. All right. Now let's look back at our chart. What's the next component? I want to note something here that over the years is a formidable challenge for most Tableau designers, and that is, if you have a chart like this and you want to sort the chart as it's sorted in descending order, how do you do that once you start changing dimensions? Because the reality is, it's easy to sort it this way. You can simply click on the sort here or the sort here, but once you change a dimension, your sort changes. And so I'm going to show you what it looks like if I hadn't done the sort technique. All right? So here's the chart, the way it looks unsorted. If I sort it, it goes back to what we originally had. But then if I switch dimensions, well, category is still shorted. I guess it's still, yeah. All right, well, usually what ends up happening, let's take the sort off and see if we can get that to demonstrate how that works. Yeah, there we go. Okay, and then you see what's happening is if I switch dimensions, the sort changes. It's not sorted, right? So it doesn't sort of look the way we want it to look. Okay, so in order to get the sort so that it is, so that it dynamically is appropriate, there's a simple technique you can use for sorting, and it works no matter if you have a single dimension or multiple dimensions or whatever. And the technique is to take the measure, sales, which I'll show you, walk through how to do it. You take the dimension, sales, and simply double-click it, and you can do this in Tableau 9 and Tableau 10. And however you're calculating dimension, it doesn't matter whether it's average, sum, total, whatever it is. You take the dimension, you start with a negative sign, you use the ZN function. ZN is 0 if null, which, for any rows of data where the sales have a null value, Tableau will replace that null with a 0. That's what ZN does. And that's it. Minus ZN, you surround your aggregation of a measure with negative ZN, and then you change it to discrete. And if you'll notice, when I changed it to discrete, it changed it from a green pill to a blue pill. I don't know how many of you were in our green and blue pill lunch and learn, but doesn't matter. When it changes it to a blue pill, you can then use this value to actually sort your data. And you can see it creates values here. The next thing you do is hide the header or turn off the header. That way, no matter what dimension you use for your data, doesn't matter what the dimension is. The sort will always be descending, and then, of course, you can change that to ascending by just removing the minus sign. So that's a little technique that will help you. And if you have multiple dimensions, so let's say we want, right now we have state, and let's say we want to add region to this. So we want to do region and then state. If you have multiple dimensions and you use this technique, all you have to do is drop this discrete pill in between the set of dimensions. Doesn't matter how many there are. Okay? Now, I'm doing something different here, so that's why the sort is not working, but I think you get the point. All right. So that's how you sort, and make sure your sort is always in the direction that you desire. Okay, so let's do that. So number one, we have our bar chart. To create the lollipop chart, what you want to do is you need a dual axis chart. You need two values. One is going to represent the stick, and one will represent the lollipop, right? Okay, and so we have our, well, let me talk about what I did to do that. I'm holding down the control key. I'm going to left-click sales and just drag it next to the existing sales, right? That creates two charts. To lay them on top of one another, we create a dual axis. Once you have a dual axis, you can see what type of charts you have, or what type of the chart types right now. We can change, and what that does is create different shells for each one of the measures. And the benefit of doing that is that each shelf can have its own chart type, right? So with a lollipop chart, actually what we're doing is we're creating two different chart types. We're creating a bar chart for the stick and a shape chart for the lollipop, okay? Now, once you do a dual axis, you definitely want to make sure you synchronize your axes. You can go to the primary axes and just click synchronize to make sure they lay on top of one another and that they're, aligned. Once you do that, for our primary shelf, we're going to change that to a bar chart. And if you pay close attention to what you see, actually what you see is a bar chart and a dot right at the end of the bar. That's going to be our lollipop. But we don't really want a circle, so we want to use a shape. And for our shape, we want a filled-in circle. We don't want a hollow circle, right? We want a filled-in circle. Then what you do is shrink down the line so you can see our lollipops are starting to take shape. And we can, if we like, we can increase the size of this. But really, I'm not going to do that now because what we want is we want the lollipop part of our lollipop chart to be actually shaped by profit, right? So we're going to take profit, drop it on size, and what that's going to do is size each one of the lollipops based on profit. Then we can change our size to something more, close to what we want. And you can increase that or decrease it based on how large you want your lollipops, no problem. And then we want to color our lollipop, the end of the lollipop, with profit. Right? Now, let's put our sort in place. I'm going to take this again and just take our little technique. Z in. Change it to discrete, take it down here, turn off the header. All right, so now we have a nice little chart. Now, and you should be able to see something that we referred to when we first started, which is Texas has a negative profit, but the size of the lollipop, the size of the end of the lollipop is actually close to the same size as a profitable state, which is Washington. How do we do that? Great. So on our second shelf, where we're sizing the lollipop based on profit, when profit is negative, we actually want to represent that size, but we want the color to be appropriate, right? So to do that, what we do is we change this from the sum of profit to the absolute sum of profit. And what absolute does is, of course, give you size. Regardless of whether it's negative or positive, it sizes it accordingly. We don't want to represent that. We don't want to do the same thing on color, because if we did that on color, we would be representing negatives as a positive, right? And that is not really what we want. What we want to do is we want to represent the size of the lollipop according to whether it was positive or negative, but the color needs to represent whether we made money or whether we didn't, all right? And so we've done that. And then what I did was, because JLL's brand colors are black and red, instead of going from an orange to blue divergent, we just use red to black. The other thing that we're doing here is setting the center value at 0. And before I do that, I'll show you how this looks. So this is the most unprofitable state that we have, but the color really doesn't indicate that, right? The reason that the color doesn't indicate that is because this is closer to pink than it is red. But, when we are demonstrating sort of a measure along a continuum and we want to demonstrate polar extremes, right? Most unprofitable, most profitable. When we're going between that, the gradient Tableau has a default position or a default tendency to sort of just lighten the colors based on scale. But you can change that simply by setting the center to 0 and using the full color range. Once again, set the center to 0, use the full color range of the gradient. What that'll do is the higher range of the gradient will be black, or this is actually gray, so we can change this to black if we like, right? So the most profitable colors will be black, and the most unprofitable will be deep red, which is really what we want, okay? So you can see our most profitable is a black color, is no longer that grayish color, and the most unprofitable is a deep red. The next thing we do is we take profit and drop it on the label, right? Now for our label, we actually we don't want this long number, right? We want to sort of format our label. So I'm going to take the label, format it, and instead of just automatic letting Tableau decide how to display the number, I'm going to display 1 decimal point and display it in thousands. Okay? Now we're getting close to our chart, right? One of the things that's really important in Tableau is to space items so that they're readable for your audience, but also to remove unnecessary, I would say, chrome from the visualization. So you'll notice the difference between this one and this one is that I've got these, vertical lines for each tick mark of the x-axis. I don't like that, right? And so what we're going to do, and in addition, my circles, my lollipop is sort of cut off, right? The top of my lollipop is kind of shaved off a little bit. So the first thing we're going to do is open this up a little bit, right, to give us a little bit more space. And then we'll adjust the size of our lollipop so that it fits within the row. There we go. And then what we want to do is remove some of the unnecessary lines. So I'm going to hide the header for the top axis because we have a dual axis chart, and we don't necessarily need all of the axes, right? So the bottom one is fine to actually represent where we are in our sales, which is what's represented by the axis here, as we can see, sales. And then we want to remove these lines. Now, removing these lines is simply formatting. I'm going to close this. You go to the Format menu, and if it's lines that you want to actually hide, you go to Lines. And then you can, check the lines that you want to actually hide, whichever ones are important to you. And what we want to do is hide the lines for the axis. Axis ticks. And I'll show you something that's a sort of a quirk in Tableau. Let me go back 2 steps. The lines that are vertically displayed here are actually grid lines. But when you go into Format Lines, you'll see that it says none, which means there shouldn't be any grid lines. But as we can clearly see, there are grid lines here, right? So what you have to do is sort of turn it on and then turn it off. It's something that's wrong. It's a bug in Tableau, right? So just know that if you're trying to figure out why your grid lines are, you can't figure out which line to turn off, it's because Tableau has a bug and it shows lines are, on when they're really off. Okay, so there we go. There's our chart. And what I did is I sort of, in order to highlight or bring forward the chart, what I also did is I changed the color of the dividing lines, right? So change the color of the drop, let's see which lines am I, oh, wait, yeah, row dividers, right? So so I'm just lightening up the gray of the row dividers so that it brings forward the lollipops a little bit more. And puts you want some type of indication of where a state stops and starts, because you have your it's sort of not easy to tell, and so lightening up those lines is a way to bring the chart forward and send the dividing lines backward, but you still have lines of demarcation for each state. Okay, that's a lollipop chart, And once again, you know, at the end of the session, you all will get the video in addition to this workbook. So we'll call this Lolly Demo or Lolly Walkthrough. Okay, now we're going to move to a reverse funnel chart. This is a, you know, I've used this chart many times in many different organizations simply because organizations usually have some form of the business or some operation of the business that starts with a number of contacts, right? We're doing some, and it's usually marketing. We're doing some activity. We're reaching out to some population of people, and what we want to do is sort of track the success of that operation, right? You're putting an ad on the internet. That ad is going to, you know, you recognize that you have, I don't know, 10,000 impressions for the ad, which is good, but what you really want to do is see how those ads transform over time, right? Do the people reach out to us when they got the ad? Did they click the ad, right? Did the ad result in an opportunity for us to demonstrate the company's value proposition to somebody who got the ad? Then were we able to close the deal, right? Whether that's selling products or whether that's getting a new customer, whether that's going to lunch with somebody, whatever the goal is, right? Most organizations have some type of operation that results in that. And these charts are a way to sort of demonstrate that activity in a compelling way inside of Tableau. And it's not really difficult to do, okay? So what do we have here? What we have here is a reverse funnel. So we can see we have some web ads, we have some impressions, and impressions basically, you know, if you put an ad on the internet and you sort of gauge that activity, an impression is known as how many people saw your ad. How many places did it appear? That's what an impression is, right? How many times did it show in a given date or in a given time block, right? And then out of that, depending on the type of ad, you could have clicks, you could have contacts, or what have you. For the sample data, I'm sort of just using the word contacts, but it could be whatever. And this is actually a Tableau chart that's based on some data. I mentioned at the open of the session that the trick to some of these charts is data shaping. And so that's the truth with this one, and we're going to talk about, I'll give you some examples of how this works. So first thing I want to do is actually look at the data for this chart that's behind this chart, right? So we have in the middle, and these are Tableau charts. As you can see, it performs just like Tableau. Now, these are shapes that I brought in, custom shapes that I brought in, but, you know, we could use a regular Tableau shape chart if you wanted to use that. So I started with this data. Now, this data has 4 columns, which is X, Y, or 4 fields, an X, Y, the value, and the metric. Real simple, right? And the goal here in Tableau is to think of your workspace or your worksheet as a grid, right, with an X-axis and a Y-axis. You have cells. Excel is the perfect tool for that, right? So let's see, I want to wipe out all of these, clear the format. And what I think I'm going to do is, well, we'll work from this. So basically what I'm doing inside of, when I say data shaping, is I'm taking my data results and I'm supplementing it with information that Tableau can use to determine where to place the element or where to place the result or where to place the metric or the dimension or what have you. The applications of this are extensive. Let me just say that. They're extensive, okay? So basically what I have is I have a grid of 11 squares, right? 11x and 11y squares, and the reason I'm choosing 11 is because there's a center point, right? You know, if you do a funnel, Basically a funnel is sort of this is more like a triangle, but you can imagine that if you just shift things to the left or right, you can actually get the sense of a funnel, okay? And so what I'm doing is I'm starting with an 11 by 11 grid because I know I have 6 metrics that I want to place on my chart. And for each metric, what I'm going to do is I'm going to give it a coordinate, right? I'm going to give it an X and Y coordinate. And that's basically what you see in the data here. Each metric has an X and Y coordinate. In order to build this chart in Tableau, you then have to sort of, use the items that you have in the data that you've put together. And data shaping basically is just the act of, contouring your data for the end result that you want. This is beneficial for a number of techniques in Tableau, primarily custom chart types. All right, so we're going to build a new worksheet, and we'll begin to use our data. Now, I'm going to just drag these two up because these are actually dimensions. The first thing we want to do is build our grid, right? Columns are the x-axis, rows are the y-axis. So there you go. You can see our grid. And if you look closely, you can actually see our triangle. It's there, right? Represented by the ABCs. We don't have any metrics here yet, so, that's why that is. Then what we want to do is we want to actually represent our values, right? So what I did is I did a combined field between X and Y, right? You can click 2 fields, and under Create, instead of using a calculated field, you can just choose Combined. And what that does is simply aggregate 2 dimensions, right? And it gives you a unique combination of 2 distinct dimensions. Now that we've done that, I'll take that and drop that on, well, we're going to change our chart type to a shape chart, right, because we're going to use some shapes. There we go. We have our shapes, and they're all according to our grid pattern, right? They're in place. I'm going to take this and drop this on, we'll drop this on label, right, so we can see our coordinates for each one. We'll take our metric, drop it on label. We can see what the label is. We take our value, drop that on metric. We can see what the value is. And then we'll take our label and we'll sort of play some tricks with the label. So the first thing is we want the label to rest under the shape itself. So we're going to change the vertical position of the label. And the next thing is we want it to be centered under the object, right? So that puts our label where we want it. And the next thing we're going to do is change our shapes. I think most of you probably, well, maybe not. In Tableau, it's really simple to do custom shapes. Now, I've already sort of put my shapes in, but I'll show you how to do this. In your My Documents folder, if you have Tableau Desktop Professional or Public installed, Tableau automatically creates a folder called My Tableau Repository on your computer. In My Tableau Repository, there are a number of folders, but one of those folders contains shapes. Very interesting. What you may not know is that you can create your own folder under the Shapes folder, and when you open Tableau, Tableau will recognize that folder as one of the shape palettes that can be used. Inside that folder, you can put whatever images you like, and I'll change my thing so we can actually see what type of images I have here inside of my JLL folder. So I got a number of different image types that I'm using, and you can use these shape images or regular images inside of your visualization, right? So we're going to take our XY coordinate, which is the second reason that I did a combination field between X and Y, because we want a different shape for every coordinate. We don't want to use the same shape for all the coordinates like we see here, because it doesn't distinguish, each one of the steps of our funnel, of our process, right? So we'll drop that on shape. And because I already set these, you can see it already automatically assigns the shape to each one of these. Now, we'll take the XY coordinate off a label. We don't need that. And I think in my example, I put the value on top of the metric name, and so we'll switch that around. All right, and we're getting close to our original chart, right? Now what we're going to do is increase the font size of the label itself so that it's a little bit more easier to read. And one thing you'll note, or one thing you'll encounter if you use this type of technique, is when you up the size of your chart, the labels kind of overlap, right? We don't really want that. In addition, I don't like the way the label is kind of hovering right above the axis down here. And so the technique that you can use in order to force Tableau to sort of move your label in a way that you want, getting the same design, is you simply add empty spaces. Now, when you add empty spaces, you want to put 2 blank spaces for each line that you add an empty space, so Tableau will recognize the empty line and won't fill it with, won't erase it or recognize it as just an empty space. So I'm going to put 3 lines on top and 2 lines on the bottom, and now this is moving our, because we have because I'm using the entire space, it's moving it up. So it really matters how you fit the chart, but we can, you can move them and then resize your shapes based on what you're trying to accomplish, okay? All right, so the size of the shape and then moving the label up and down based on empty spaces is how you accomplish that. Now let's make sure we're, bottom center. So I've got too many spaces on top. All right, great. Yeah, I did something funky. All right. So anyway, I think you get the point with that. Let's see, and then because your axis, you don't really need to see these, right? They're not important. You can turn off the header for those, and your users don't actually know that you're using a grid. All they know is that, you have a nice little design here. What did we do here? It's really not taking effect, is it? All right. Bring these down.
Did you add a space at the bottom of the label?
Yeah, I have a space at the bottom, but oh yeah, there we go. Too many spaces at the bottom. There we go. All right. I'm glad I have you on my team, Renee. I got to tell you. Thanks, my friend. Okay, so we've got our chart, right? And it looks similar to the one I did before. The icon's a little bit larger. Okay, so that's how you build a reverse funnel. And like I stated before, if we wanted to have our funnel kind of go up this way, right, you could add more rows to condense the shape if you, want to do that. And you can also change the shape, change the chart type when you do things like this. So, if we go with an area chart or different, you can actually change different chart types. But if you have shapes, then of course you want to use shapes. Okay, the point here is that you can actually use a grid type of format or axis and coordinates to actually place things on a Tableau worksheet in specific areas the way you want, right? And so you can take this technique and use it in many, many, many different ways. For example, let's say you actually want to report metrics. You're not looking for a funnel or a triangle, and you're not trying to demonstrate that. What you want to do is create a chart that has many different metrics. Let's say 5 or 6 or 12 different metrics, right? And you want to demonstrate that experience in one worksheet. Well, this is a technique you can use because you can put something in each one of the coordinates, right? You can have a number here, 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 and here, right? 6 on top, 6 on the bottom. And the benefit of using one worksheet as opposed to 12 different worksheets with one metric on each worksheet is that it is a performance boost just to put everything on one worksheet, because Tableau, in order to produce that worksheet, only has to run one query. If you have 12 metrics and you use one worksheet per metric, Tableau has to run 12 queries. Right? So that's another added benefit. Okay, we're going to move to the next chart type, speedometer. Ooh.
Hey, Dwight, this is Renee.
Yes.
I have one question before you move on.
Yes.
These shapes, so since you imported them and they initially reside in your locally on your machine, is there anything you have to do when you publish this dashboard to Tableau server in order for these shapes to import as well?
That's a great question. So let's take a look. And we'll go to not the Amazon site so they don't wonder what we're doing here. And we're not going to actually publish. I am going to change sites though, so I don't, make a mistake and mess up. So it's a great question. So let's answer Renee's questions about publishing. So in Tableau Desktop, there is something known as external files, right? That is shape files, that is Excel files, that is Microsoft Access databases, that is text files, CSV files. When you publish your workbook, Tableau has an option under the More Options section of the Publish window that says Include External Files. Now, if you're working in a Tableau workbook on your desktop and you haven't explicitly saved your workbook as a archive or packaged Tableau workbook, which has the file extension TWBX, Tableau by default will save it as a TWB, which means instead of putting the image files inside of the Tableau workbook, it'll just reference the files from where they live in the Tableau repository, which is the folder that we saw earlier, right, in the My Tableau repository. The moment that you save it as a TWBX, Tableau puts everything inside of a nice little zip archive, including the images. But when you publish, if you don't include this check mark, Tableau will, and see it gives me a message when I do this. It says, this workbook refers to external files, data sources, or custom geocoding. Published views will not function correctly unless Tableau server has access to these files. It gives you a nice little warning and an explanation as to what you're doing by clearing this check mark. So the answer to your question is, if you include custom shapes or you have external files like spreadsheets, you want to make sure you check this. And by default, when you publish, Tableau turns this on because it recognizes that the workbook that you're trying to publish uses external content. So it does turn it on by default.
Okay, thank you.
Does that answer your question? Okay. Right. Somebody's calling somebody. It's definitely not me. Okay, so we're going to move to our speedometer chart. Speedometer, all right. Has anybody on this call, well, maybe I shouldn't ask that because we have a lot of people on the call. I would endeavor to say, because I haven't seen it and I've looked at all of the workbooks that exist across the JLL infrastructure, I haven't seen anyone use a speedometer chart yet. And I pretty much know why. Speedometer charts are not simple to create. And the reason that they're not simple to create is because it demands that you shape your data in a certain way. And you create calculations that give you the speedometer that you want, right? And so while I'm going to talk about this and show you this technique, my encouragement is, if you're really interested in it and you want to use actual data to do this, that, we need some maybe time. I don't have too much time left at JLL, but if you're really interested in doing this, I can walk you through it. Today, what I'd like to do is walk through the components of doing this, okay? What you'll first notice is that we have some XY stuff going on here. Now, let's talk about this. the coordinates that you see there are map coordinates. The reason that they're map coordinates is when you're trying to do something that has a dial, a moving thing in Tableau. And basically, you know, if we, let's see, let's take, what are we using? We're using country, put that on shells. You know, we can pretty much automate this dial chart. Let's go back. Okay, I won't do that. We can automate this. We can automate the dial over time if you wanted to show. So, and basically, what I'm trying to demonstrate is you can actually automate stuff in Tableau using the pages shelf. Okay. All right. We won't get off into that. Let's talk about this. So we're talking about, we have X and Y coordinates. The reason we have X and Y coordinates is because this image that you see that the dial is on, the image itself is actually a map background image. Okay? So it's a map background image. Inside of the reason, the second thing that makes these charts sort of difficult is you really need to understand your data, right? You need to understand max and mins in your data, or the range that you want the dial to go through in your data. And depending on image type, you don't want the dial to go 360 degrees. So, for example, if this dial actually pointed down here, it would look kind of crazy, right? So when we talk about data shaping and we talk about things like speedometer dials, I'm recommending a sort of separate conversation because, you know, it requires some detailed explanation as to how to shape your data. We're going to talk a little bit about it from this data, but I want to show you how the background, how we bring this image into a worksheet. It's a map background, but the map background image is just one part. The second part is delineating the negative and positive coordinates for X and Y axis. Because the way a speedometer chart works is that the needle moves along the X-axis and the Y-axis. But the Y-axis, unless you want your needle moving up and down, you really want the Y-axis to stay the same, right? You don't want the center point or the rotating, you know, the center point of the needle to move. You want the needle to move along a sort of arc, right? And in order to simulate that, you have to simulate X, Y coordinates. That's how you move the needle. And in order to do that, you have to shape your data, right? So let's look at the X coordinate. It's a very simple calculation that's driven by our data results, the things we actually want to demonstrate using the speedometer. And what we're demonstrating is, how sales compare to the budget percent of the budget, right? So if we have a, I don't know, $1 million budget and we did 500,000 in sales, that's a 50% needle, right? So the needle, if that's the calculation, the needle would sit straight up. And so essentially what this chart is telling us is how much each country contributed to the overall budget, the percent of the budget, right? So U.S. is 50%, or, well, it's, so contributed moderately, let's put it that way, since it's a speedometer. The UK is in red because it contributed a very low percent to the overall budget. France did better than the U.S., and Germany did worse than the U.S., right? The U.S. was right in the middle here, if we go back, right? So what this chart is telling us is how each country contributes to the overall budget, right? What percentage that they're contributing to the budget. And so if we go back to that calculation, the calculation is, number one, based on row type. Now, what I want to do is show you the actual data behind this in a second. But what it's doing is it's taking the sign of the sales divided by percent of budget, turning that into a percentage, multiplying it times 90 times pi and by 180. The reason we do the pi times 180, as you might imagine, is because we're trying to calculate a value along an arc, right? For those of you who sort of remember mathematics in high school or grade school, if you want to plot something along an arc, pi is the way you use it, and a degree, right, the angle degree. And the reason we're using 180 instead of 360 is because, as I mentioned before, we don't want our needle down here because we're not using a full rotating dial. We're using a 180. We only want the range of the dial to flow from 0 to 180, right? If we wanted it to turn all the way around, our calculation would be modified to include 360 here instead of 180. Okay. Same thing for Y. It's a calculation, and instead of the sine, what we're taking is the cosine. Now, it's really not my endeavor to sort of get into these. However, it's relatively, you can see what we're doing here, right? For the x-axis, which is along this continuum, right? You take the sine. For the y-axis, it's cosine. And what we're doing is plotting a point along the axis. And then this is simply a line chart. You can see what type of chart this is, right? It's just a regular line chart. So that's the thing that's actually moving. What we're doing is actually moving a line along a path, okay? And the path is represented by the dimension row type, which is why in the calculated field, we're actually looking at the row type here. Okay. By the way, for Tableau users, I think most of you probably already know what adder is, but I'll explain adder a little bit. And so, for example, I'm going to do something. I'm going to actually take adder off of here. And what that does is create an error in Tableau. And I'm going to read the error for those because it's kind of small type. It says you cannot mix aggregate and non-aggregate comparisons or results in an if expression or an if clause or an if statement. The reason it's saying that is because there are two types of ways you can build a calculated field for a speedometer chart. One way is you can do row level calculations, and the other way is you can build a calculated field that acts after Tableau has done all of its aggregating, right? But for dimensions, how do you do that? Well, adder is how you look at the value of a dimension after aggregation has happened, right? And so basically that's what adder is. Allows you to look at a dimension after Tableau has aggregated all the measures in a view. And the reason this is significant is because when you're building a speedometer chart, you want the needle to move based on the result of the calculation. You don't want the needle to move based on the result of a row, especially if you have atomic level data, all right? That's why that's important. And then we have our regular calculations down here, okay? All right, I think that's all we need to talk about from this chart. Oh, let's go back to the map background. Oh, we talked about that, didn't we? All right, so I have a different speedometer image in here, which has the I'll show you this. It has the same length, left and right coordinates for X and bottom and top coordinates for Y as the previous image. So swapping out an image, as long as you fill in those values, is really simple, right? We can change it, and it still sort of does the same thing. It doesn't change the moving of the needle. It just changes what is behind the needle, okay? And so in Tableau, this is something that's also sort of important to note. In Tableau, you can use what's known as a sleight of hand, right? And so we can actually change this chart to a bar chart. We could put some other image behind here. Now, I'm going to warn you that data visualization purists hate this type of chart development in Tableau. The reason that they hate it is because you have to actually make Tableau do something that it doesn't normally do, right? Speedometer charts are not normally built in Tableau. So anyway, that's just a note for those of you who are endeavoring to build these type of charts. And once again, if you want this needle to rotate in a full circle, no problem. You'll get this workbook. You can actually leverage this chart type. Just change the note, change the 180 to 360, right? And putting in your standard values. And that will prevent the needle from, or allow the needle to go past 180 degrees. Okay, I think that's it for today. Are there any questions on what we've shared today? Once again, this is Beyond. Yes.
Can you go back to your formula for the x-coordinates really quick?
Sure.
I just want to make sure I'm understanding this right. So basically what you're doing is you're saying if the attribute equals dial, then give me 0, and that's in both the x and y axis, and that's how you get the first piece of the line to always stay constant in the center, right? And then the other piece, else, is where you're figuring out the endpoint, right?
Right. Now, what I need to show you, which I failed to do, sorry about that, I said I was going to do it, is show you the data. Right, so let me open this up a little bit. And you can see, so back to my original sort of comment, it's all about data shaping. Doing these type of charts is about data shaping. Because in this chart, you actually are doing two things. You're aggregating the data, but you're moving the needle based on the aggregation. So you're doing two different things. And using an adder if allows you to evaluate the atomic roll or the post-aggregation value of a column in addition to actually mapping a value of different rows than the row that you're actually looking at. So as you can see here, this data has data rows, it has dial rows, and it has data rows. There's only one row that says dial. The reason that you add this row in is because you want to use this row to evaluate the aggregation of these, right? The sales and the budget percent. Okay, hopefully that sort of makes sense, does it?
Yep.
Okay, perfect. Great. That's a great question. Sorry about that. I told everyone I was going to show you the data. I totally forgot to do that. Anyone else?
Hey, Dwight, can we post this workbook somewhere, too, in case people want to dig in and play around with the raw data?
Oh, absolutely. The workbook will be available to all of you all. It'll be available in the ongoing learning self-service CI website.
Thank you, Dwight.
Okay, listen, thanks, everyone. Have a great afternoon, and happy tableauing.
Thanks, Dwight.
Thank you.
Thanks for joining.